Is it started? Yeah. Hello. Guess who this is? This is Miss Melinda. Welcome to Miss Melinda's Spontaneous Smart Diva Show. Tonight I decided I've taught so much the judicial system class and so much of Mars and the exoplanets and the solar system. I've still got a class tonight with NASA and the solar system. But first, I decided find something way different, completely different. Like I was going to do with after NASA, I was going to do the formation of Earth, and I'm like, no, do some stuff way off the wall, to get these people's attention. So I got a book. It's called 1,000 Questions and 1,000 Answers. And you go in the back, and they have a bunch that are real short questions and real short answers. And they, hold on. Okay, so they're really weird. Wait, my computer over here is freaking out on me. Hold on. How do I get this out of here? Hold on. Okay, just leave it. So I said, I'm going to get some really off-the-wall subjects that a lot of them guys are like, a lot of kids are like, or a lot of guys, men, or little boys, but girls will love them too. So here we are. I'm going to start this class first, and then we'll do your expected NASA class with the solar system. And I actually am working for NASA because it was in one of the pages 2 days ago. It said, citizens can help. And they gave a list of ways you can help with this, looking for these planets outside the solar system and etc. And one of them said, you can teach. One of the things they offered is you can teach. And I said, well, I'm teaching you right now, NASA. So I guess I'm literally working for NASA because I am teaching NASA. And that was one of the ways they said you could help. So I am officially working for NASA. But we're going to take a break from everything. And we're going to do short questions and short answers. And you guys will really be interested because these are subjects nobody thinks of. Okay, so let's get started. This is Miss Melinda's Spontaneous Smart Diva Show. And tonight we're starting with a book called 1,000 Questions and Answers book. Okay? So, I don't think I like this over here. This I'm going to have to fix this. Hold on. We can't do it like that. I can't be grabbing the... Okay. So here we are. Let's do this. Different class. Okay. How do helicopters rise vertically? How do helicopters rise vertically? Now, doesn't that get your curiosity? Has anybody ever brought that up to you, any of you, and said, hey, do you know how helicopters rise vertically? Has anybody ever asked you that? Probably not. So I'm going to. How do helicopters rise vertically? Helicopters have one or two large rotors made up of long, thin wings. When the rotors spin around, they lift the aircraft and drive it along. Helicopters can fly forward, backward, and sideways. The first single Blade helicopter was built by Russian-American Igor uh, Igor Sikorsky in 1939. Okay? All righty. So, next question. So, did any of you know the answer to that question? I have a feeling maybe nobody had the answer. Okay, the name of the person and that year and all that stuff. All right, here's one. Fascinating. Who would think of this one? What were Zeppelins? Okay, spelled Zeppelins. What were Zeppelins? Well, they're saying it the whole time past tense, but acting like they don't exist anymore. But I see these up in the air a lot, especially in the summertime, especially if you're like on the beach down in Florida or even in Chicago. I think that'd fly by. But they're talking like they're history. Well, I'm going to have to look that up. I didn't get a chance to do that. So, what were Zeppelins? Zeppelins, named after their German inventor, Ferdinand von Zeppelin, were giant airships up to 800 foot long. They were powered by gasoline engines and a propeller, and were filled with hydrogen gas, which is lighter than air. Can you believe that? They were filled with hydrogen gas, which is lighter than air, but very flammable, very flammable. The first Zeppelin flight was in 1900. Okay, so that's a fascinating one. Do you know what I'm talking about? Did I describe? This is all the information the book gave. Is it enough information that you know what I'm talking about? Have you ever been laying out on the beach or even around Chicago in this? I don't know. I always thinking it's like in the summer, maybe 1 or 2. They'll be advertising something, and it'll be a big, huge, like balloon, as big as an airplane, but it looks like just like this long balloon. Yeah, and there's no windows, you can't see. Yeah, I don't even think you see, how airplanes have wings. I don't even see wings on those things. So I don't know why they're talking like they're all in the past, because I see those big, huge air balloons. They'll advertise, like on Daytona Beach, oh, suntan lotion, or tonight, go to this bar, or buy this coconut. They'll, fly, and they'll have an advert, and it's a Zeppelin. It's the same thing. So anyway, I just bet you never thought anything. You probably didn't know who. So the guy was German, the inventor, and is Ferdinand von Zeppelin. So they named it after his last name. All right, here's the next question. Aren't these different though? Something refreshing, not the same. The whole class, same, like, It's a whole bunch of different questions that have nothing to do with each other, and they're questions you never think of. Here's one. Who was the first hang glider? Who was the first hang glider? Otto Lilienthal, a German engineer, designed and flew over 15 different hang gliders. He made the first flight in which the pilot controlled the machine. Otto died in 1896. He crashed in one of his hang gliders. Otto died on one of the thing he loved, his love that he loved in life, is what actually took his life, and that's sad. So yeah, he crashed in one of his gliders in 1896, and that was the end of that. So that was very interesting. Okay, we got next question. Aren't these refreshing, you guys? Instead of exoplanets and the freaking red dwarfs and the stars, or law class, this is all a bunch of different, really off-the-wall subjects that people just don't think about. Here's one on the sea. Okay, so these couple pages has a bunch of on the sea, but I only took like 2 stories from this. I only take a few from each like subject. Oh, there's a million subjects. This book is big and thick, so I'll be teaching you from this book a long time. And if I ever finish it, I'll start another one that's got real weird stuff. Okay, on the sea, it's called. So you know it's going to be about the sea. Okay, early people traveled over water using rafts and dug out canoes. About 5,000 years ago, the Sumerians and Egyptians built ships with sails and oars. In the 1800s, steam engines took over from sails, and steel replaced wood. I don't know what steel replaced wood means. 100 years later, ships with gasoline engines took to the waves, okay? And then when were paddle steamers first used? Does anybody know the answer to that? When were paddle steamers first used? Can you guess the century? The Frenchman, Geoffroy d'Abens, the first working steamboat in 1783. Did anybody know that? No. Within 20 years, paddle steamers were being used to ferry people and goods up and down rivers across sea. Okay. Here is a little more about sea. I thought this one would be interesting. A lot of people are interested in our different, the Army, the Navy, and all that stuff. So I did this one. So this one is about sailors, okay? Let's see if any of you know about the sailors in this, okay? So in the mid 1700s, 2 British inventors helped sailors, keep your paper down, Melinda, helped sailors fix their position at sea. Okay? The sextant, it's called the sextant, sextant. The sextant, invented by John Campbell, determined latitude by measuring the angle of the sun or stars above the horizon. That's fascinating. Where am I at? Okay, John, here, wait a minute, what is this? John Harrison's chronometer, a kind of clock, helped measure longitude. Who knew that one? See, these are fun. Isn't this getting your mind off of the stuff I keep teaching you the same? These are like all unrelated and short questions and short answers, but they're really interesting topics, aren't they? Yeah, to learn. So, when were submarines invented? Does anybody know when submarines were invented? Okay. In 1620, Dutchman Cornelius Drebbel's wooden submarine rowed by 12 oarsmen traveled several miles up the famous river in London, England. Hey, see that? They traveled up the famous river in London, England. I think there's a little more to it. There is. There's more to it. Submarines continued. The first submarine was named the Turtle. The first submarine that could rise and sink was designed by American David Bushnell in 1776. Isn't that the bicentennial year? Well, that's a weird coincidence. Yeah, it was the bicentennial year when the year before I graduated high school. We graduated in 1977. In 1976 was the bicentennial 200 years from 1776. Yeah, that's pretty interesting, isn't it? Yeah. So the submarine was used in the American Revolution. The submarine was used in the American Revolution. Fascinating. I bet you didn't know that one either. Now listen, this is a kick-ass one. This one is going to blow you away. This one is a good one. And I'm going to investigate this tomorrow. You know how they always talk about the famous speed of light with Einstein? Okay, I don't know exactly how to say that, but how it's like impossible to blah, blah, that kind of thing. Well, somebody did this, and it sounds like that means they beat Einstein. Here it says, and this is not that many years ago. In fact, I was a junior in high school. Okay, guess what this says? Can glass fibers talk? Okay, optical fibers are strands of glass twisted into a cable that can transmit light. Period. In 1976, Charles Keogh and George Hickman had the idea of using them to carry telephone calls at the speed of light. Well, how could they carry telephone calls at the speed of light? Isn't the whole thing, I don't know the cliche, but isn't the whole thing of Einstein is mankind cannot beat the speed of light? And they're just saying here, had the idea using them to carry telephone calls at the speed of light. So doesn't that bust Einstein's theory? I don't know what the cliche is exactly, but from what I know is you can't beat the speed of light. That's what I thought Einstein's theory is. And it says that they are carrying the telephone calls at the speed of light. That just doesn't make sense. I'm going to have to investigate that tomorrow. But I bet you never heard that before, did you? Anybody here? That they turned optical fibers, glass twisted into optical fibers are strands of glass twisted into a cable that can transmit light. In 1976, Charles and George had the idea of using them to carry telephone calls at the speed of light. How can they do that? I thought that's making Einstein not right. So I must not know exactly how Einstein's theory goes. I'll have to look that up. The first fiber optic telephone link was set up in America in 1977, the year I graduated high school. Okay, here's a good question. What are microchips? Okay, so this ain't that old of a book. In the 1960s, I didn't know they had microchips. When we went in the 1960s in grammar school, they took us to the IBM building on Michigan Avenue down in Chicago that still exists. And they took us into the big computer room. And you should have seen the size of these computers because it was the 60s. I was in grammar school. So the computers were from like 15 feet tall, from the floor to like a 15, 20 foot high ceiling, and all the way around the walls next to each other. Yeah, it was fascinating. So I didn't know they had microchips that far back. Okay, so here we are. What are microchips? In the 1960s, scientists came up with a new way to run computers. They used a tiny slice, or chip of a material called silicon to make the electronic, quote-unquote, brain. That controls a computer. So they're saying they came up with material called silicon to make the electronic brain, quote-unquote, that controls a computer. Today, tiny microchip contains up to 250,000 parts that tell it how to work. A computer uses different microchips to do different jobs. Oh, and that's it for this class. So how do you like my diva costume? I really felt like you guys were getting bored, like feeling like everything was like repetitious. And I just thought I have to come out in a different type of diva costume that's really different. So here I am, and I thought that was a really fun class. And we got another class. See, I'm giving you 2 classes tonight. We're back to NASA. Okay, but at least you got a nice break. You got a nice break. Let me see how many pages I got here. So you got 14 pages. Okay, we're back to NASA. But that's good. You need that. All right, here we are. So now we can take our coat off. And now you can see my black and white costume. I've been wearing black and white every night since I finished the last class of the judicial system. And I started the solar system, and Mars, I've been wearing black and white every night for it. It just became kind of like a ritual for Mars, test, the solar system, outside the solar system, the entire universe, galaxies, and whole black holes. So I got more information for you on black holes. Yeah. Okay, so here I am. I'm still in black and white. And now we can take the sunglasses off. Hello, everybody. Did I at least make it a little exciting? Did I give it a little bit of some excitement? That was a little different, right? I kind of shocked you with the diva glasses. And this is a Japanese coat I ordered over the ocean. And I've never worn it. Not yet. Okay, so here we are, ladies and gentlemen. And we are still rolling the camera. Okay. Wait, what do I got going? I got to fix the bar right. How's the barrette going? Is this here? I have to get this barrette tighter. Okay, there's that one. Now I have to pull this hair up and then chop it. Got it. Now my hair won't fall down. Okay, here we are. Okay, now you get to see Melinda. Let me see what my makeup looks like. Oh yeah, so this looks good. Oh yeah, if I can keep it up here, it looks beautiful when I put it up in the air. Okay, well, let's try to put it up in the air then. Alrighty, see how we can do. You can have it put these things. Put this away from the cord, Melinda. And put that over there. Okay, so here we are. Now here's my new black and white costume. Okay, let's get started. Now stay right there, okay. Because that light back there, yeah, okay. So, but I do need to be sideways. Like that, does that look better? I have to make sure I don't look, like a jolly green giant fat. Well, you have to be on a certain angle. See, that don't look right. You have to be sideways. Yeah. You have to be sideways. Okay? How's that? I think that looks good. See, I don't have my chest all the way across the whole screen. And we can even take the jacket off. We'll do that. Let's go a little bit with the jacket, and then we'll take it off. But as of right now, as long as I'm sideways, I don't think it's making me look too fat. No. It's all just the angle, Okay, let's go. NASA, page 1. Astronomers have discovered an Earth-sized planet. Put the paper down, Melinda. An Earth-sized planet orbiting an ultra-cool, quote, red dwarf star, quote unquote. It's called ultra-cool red dwarf star. Similar in size to Jupiter, the red dwarf, located some 55 light years away. See, that's why we have to keep watching these videos over and over, because they'll have in another class it'll say something's 55 light years away, or there'll be something to do with the red dwarf, So you have to keep watching these over and over until it sinks in your head each class, because there's a lot of repetition, but it's telling you a whole different thing about in the solar system. Like Tess, there's still a million more things to teach you about Tess. But I needed to give Tess a break, or you would lose interest. But you won't, because it's fascinating, all that stuff. But we just got to break it up some, and that's what we're going to keep doing. Okay, so astronomers have discovered an Earth-sized planet orbiting an ultra-cool, quote, red dwarf star, similar in size to Jupiter. The red dwarf, located some 55 light years away, is 100 times less bright, 100 times less bright than the sun, and exhibits half the temperature of our star. This artist's concept, it had a picture, but I obviously can't show you it. Maybe someday I could show the book. I never thought of trying to do that. Let's see. Well, this ain't a book. I'm taking this off of NASA, which is off the computer. Yeah, so I can't show you the picture. Anyway, well, I could take pictures of that Okay, we'll think about it. Let's move on. So anyway, the red dwarf located some 55 light years away, 100 times less bright than the sun, and exhibits half the temperature of our star. Paragraph. This okay, paragraph. This artist's concept from 2015 shows exoplanet Kepler 1649 c, lowercase c. I guess 1649 is part of the Kepler. I guess it's the name of a telescope, and they always have numbers. So I don't think 1649 is the year. I'm not sure. I'll have to look that up another time, because it always has numbers, the telescopes, after it, and it's got a lowercase c by the number. So I don't know how it could be a year. Okay, orbiting around its host. So the temperature of our star, okay. Are they talking about the sun? I don't want to read this all over again. Orbiting around its host, red dwarf star. Here, let me start the paragraph. This artist's concept from 2015 shows exoplanet Kepler 1649 lowercase c floating off to the side, orbiting around its host, red dwarf star. This exoplanet is in its star's habitable zone, the distance where liquid water could exist on the planet's surface, and is the closest to Earth in size and temperature found to that date in data from the Kepler mission. So yeah, I think it's a telescope. Maybe we're ready for me to take my jacket off. Yeah. That'll be, we still got black and white on. That's what we're wearing every day. It's just a little thing I'm doing with this NASA, solar stuff and NASA. I'm just playing around. But let me put the white, so that the white shows. Okay. So, see my cute costume? Isn't this adorable? Yeah. I love it. Yeah. And I think you got it perfect. You have it perfect. Yeah. See, I don't look fat now. You always have to be on the right. Well, I stood it up on its own. Yeah. Okay. And it came out beautiful. It's actually blocking a big light that would have been bothering my eyes. I got it angled and set right where it blocks this one light. Yeah, this is a cute black and white costume. See, all my black and white costumes are original fashion, right? I'm not like Sharon Osbourne on the talk, Ozzy Osbourne's wife, wearing the same black and white jacket. Just $88 million, and you don't even want to change your clothes. You don't even want to come in with a different crop jacket on and top. I just can't fathom that concept. All that money, clothes are fun. Yeah, and you're on TV. You're being seen every day. They actually, the CBS, and that Asian lady that started the talk, her dad owned that show, The Talk, I think, and CBS. I think she might have said he owned too. But CBS is a big channel, because that's all what Cher was on, from Sonny and Cher. All right, let's move on. So, anyway, each one of my black and white costumes are different, are all very different and very cute, aren't they? I just love them. Okay, so here we are. Let's get started again. Page 2. Okay, page 2. The Kepler mission was specifically designed to survey our region. Oh, I gotta take my boots off. I can't. I would show you them, but I can't move. I got the tablet too perfect. If I move it, I'll never get the tablet back again. Okay. But I have white cowboy boots on that go up to my knees with fringes. See the fringes? Yeah, that's what I'm wearing. Okay, there. I'm gonna start showing you guys stuff in the camera. Okay. Never a dull moment with Miss Melinda. No, never a dull moment with Miss Melinda. We have lots of fun. Yeah. Let me get into my laptop here. Okay, I can't see. It's not right. Sorry, guys. Hold on a minute. It's not letting me. There. 9. Yeah, tell the whole world. All right, let's get in here. And let's get in here. Okay, so number 2. Okay. I'm coming, guys. All right. I'm just getting into my YouTube on my laptop. All right. So there you are. Okay. So, here we go. Okay. See how cute the bows go down far? Oh, keep that bow up there. Yeah, that's cute. Okay. All right. The Kepler mission was specifically designed to survey our region of the Milky Way galaxy to discover hundreds of Earth-size, quote-unquote, Earth-size, and smaller planets in or near the habitable zone, and determine the fraction of the hundreds of billions of stars in our galaxy that might have such planets. Paragraph. One of the most fascinating discoveries is the exoplanet. It's Speculus -3 with the lowercase b floating off to the side down a little bit. So it's all uppercase. Speculous. Speculos. -3. Lowercase b floating there. That is discovers of the exoplanet. It's the name of the exoplanet. That's how all the way they name all the exoplanets. If you start, go back and watch all my solar system and NASA, because all the titles to the exoplanets are all similar, just like what I read off to you. All right, so yeah, so if you've been watching if you watched all of my NASA and all of the solar system and watch them over and over at your own convenience, and then if you watch the judicial system, that's real important too, and watch it a lot. And then just when you want to have fun, jump around to the other ones. I look real funny though in a lot of videos in the beginning. Some came out beautiful, but a real lot I was struggling with that tablet. So I look like you're thinking like I'm like some mental person. I got my head stiff. I'm talking weird, Okay, so anyway, here we are, and we are much better shape. You had to learn. I never had a tablet. Had to learn. Okay, so next paragraph. One of the most fascinating discoveries is the exoplanet Speculus 3b, which orbits an ultra-cool red dwarf star. This Earth-sized planet is located about 55 light years away. Now, how do they know this? From Earth. Isn't that weird? I got to Google that. No, I Cortana it. My Microsoft assistant will talk to me. She answers everything I say. Okay, so it says this Earth-sized planet is located about 55 light years away from Earth, making it relatively close in cosmic terms. The planet is tidally locked, meaning one side always faces the star, while the other remains in perpetual darkness. Okay? Although it likely lacks an atmosphere due to intense radiation from its star, its discovery highlights the potential for exploring rocky planets around ultra cool dwarf stars. The Milky Way has been a treasure trove of discoveries, and NASA has played a pivotal role in unraveling its mysteries, okay? I have to ask a bunch of really weird questions to get this information to you guys. That I don't just go into NASA and this all pops up. I have to say, hey, can you send me a interesting, most exciting, sensational of this, that, and this, and this and that. And it has to be something that nobody else will think of. You know, my mind's manic, so I think deeper and heavier than the normal person. And so I'm not just looking up and then just getting this. I have to ask 100 different questions to get this stuff. Yeah. Okay, so where are we at? Okay, page 3. Page 3. One side always faces the star, while the other remains in perpetual darkness. Although it likely lacks an atmosphere due to intense radiation from its star, its discovery highlights the potential for exploring rocky planets around ultra-cool dwarf stars. Next, the Milky Way has been a treasure trove of discoveries, and NASA has played a pivotal role in unraveling its mysteries. I know I already read this, but it's good to hear it again. Here are some highlights. 1. Mapping the Milky Way spiral arms. Astronomers discovered that the local arm of the Milky Way, where our solar system resides, is 4 times larger. Okay, 4 times larger than previously estimated. This revelation reshaped our understanding of the galaxy's structure. 2. Exoplanet exploration. NASA's Kepler Space Telescope. Okay? NASA's Kepler Space Telescope, which we've been reading about, has identified thousands of exoplanets. So see, these telescopes, it'll take me the rest of my life to tell you all the discoveries. They tell you there's more and there's more discoveries. And here it is. And you know, the internet's infinitive. Well, so is this stuff. Yeah. So I'll be teaching this the rest of my life, and I'm enjoying it. So exoplanet, this is 2. Exoplanet exploration, NASA's Kepler Space Telescope, quote unquote, has identified thousands of exoplanets within the Milky Way. Can you believe this? Has discovered thousands of exoplanets within the Milky Way. But that's got the black holes, I thought. Many of which could potentially harbor life. Did you hear this? Let me repeat this. So the Kepler Space Telescope has identified thousands of exoplanets, okay? Thousands of exoplanets within the Milky Way. There's thousands of exoplanets within the Milky Way. We never heard of this. We never heard of planets being in the Milky Way. I never heard the planets being outside the solar system. Those are two things I didn't have a clue. I thought we only had planets in our solar system, period. Because I didn't have most scientists, teachers didn't get it into that deep like that. Okay. So the Milky Way, many have which could potentially harbor life. They're saying there could even be life on these thousands of exoplanets in the Milky Way, which is also the galaxy. And I looked them up for tonight. It's coming up here. The galaxy with the black holes. So it says identified thousands of exoplanets within the Milky Way, many of which could potentially harbor life. This has expanded our knowledge of planetary systems. Isn't it fascinating to think? What do you think? Do you think there's humans? It's potentially could have life. They have enough evidence that it has the capability of possible life. What kind of life do you think it is? Do you think there's human beings? What do you think? Do you think it's just plants and animals, no people? Do you think they're like they don't look human? Maybe there's some kind of Martians. We're like the typical Martian they show you with one eyeball and a big head, skinny little neck, and the E.T. phone home movie. They always identify aliens to look like that. Why don't they come up with some different descriptions of what, when they make a movie, make the alien look different. Every time they make an alien movie, they always look like the same as the movie that Drew Barrymore starred in, her first show as a real little girl. They always make the aliens look like E.T. phone home. Make them look different. Get some creativity, for Christ's sake. Okay, so 4 times larger than previously estimated, this revelation reshaped our understanding of the galaxy's structure. 2. Exoplanet explorations, NASA's Kepler Space Telescope has identified thousands of exoplanets within the Milky Way, many of which could potentially harbor life. This has expanded our knowledge of planetary systems. 3. Star formation insights. Using radio telescope, scientists have pinpointed star-forming regions in the Milky Way. Star-forming regions in the Milky Way, helping us understand 4. The galactic neighbors, The Milky Way is part of the local group, a collection of galaxies including Andromeda, and several dwarf galaxies. See, I didn't know that galaxies were called dwarfs too. I don't think all galaxies are called dwarfs, just some. Guys, we've been hearing red dwarf star. We keep hearing red dwarf star. That the dwarf's a star. The dwarf's a star. I never heard of say a galaxy can be a dwarf. That's what I was telling you the other day, that dwarfs can be many different things. That much I knew because I studied that white book on and off for some years, and teaches you about things that turn into dwarfs and they flow away. They blow away like a balloon. Like if you let a balloon go off into the air, things will turn into a dwarf and they'll blow away into the air into nothing. And so I knew there was other things called dwarf, but I didn't know that that a galaxy could be a dwarf. So that's a new lesson. I don't think you knew that one yet. So I don't think I taught you that a galaxy can be a dwarf. No, but I did teach you, I know that dwarfs can be many things and that we would come across them. In fact, I'll do a whole bunch of research on, tell me all the different dwarfs you could come up with, how many, where they're at. Yeah, that's a good one. All right, I'll research for you guys tomorrow about how many dwarfs and how many different things turn into dwarfs. And do they disintegrate completely when they turn into a dwarf? I think the sun disintegrates, and when it gets fried up when the sun gets fried up from its own heat, I guess, it turns into a dwarf, I think. Okay. But don't quote me on that. All right. So, including Andromeda and several dwarf galaxies. Studies of these neighbors provide clues about galaxy evolution. 5. Cosmic scale. NASA has helped quantify the Milky Way's vastness. I did research on the Milky Way and the whole black holes and the galaxies all together. So that's why you're getting all this. Here, let me start over. 5. Cosmic scale. NASA has helped quantify the Milky Way's vastness. It's about 100,000 light years across and contains up to 400 billion stars. How can they come up with billion stars? How do they count and go, oh, we just hit a billion? How do they do that? I'm going to try to Cortana that. I call my assistant, my Microsoft assistant, Cortana. Okay, so it's about 100,000 light years away across and contains up to 400 billion stars. The Milky Way is a cosmic wonder, and every discovery brings us closer to understanding our place in the universe. Okay. Boy, I'm actually starting to get an appetite. I got some food saved. NASA. Black holes are among the most fascinating phenomena in the universe, and their relationship with galaxies. See, I Cortana'd this. I used my Microsoft Assistant I want to know the most exciting for my students about black holes and the relation of black holes with galaxies. And so here's some of the stuff they're giving me. NASA, black holes are among the most fascinating phenomena in the universe, and their relationship with galaxies is equally intriguing. Here are some highlights, because I asked about this. 1, galactic evolution, : black holes play a crucial role in shaping galaxies. Now, I bet you didn't know that, did you? Let's read that again. Black holes play a crucial role in shaping galaxies. I do remember talking about sucking something in horizontally and then turning it vertically, or the other way around. Yeah, so it says black holes play a crucial role in shaping galaxies. And we did have one sentence saying black holes change the shape of something from vertical to horizontal, or something like that. Anyway, so they play a crucial role in shaping galaxies. Supermassive black holes at the centers of the galaxies. Okay, so we got supermassive black holes, so lots of them, not just one, of the centers. They're in the center of the galaxy. Well, how come it doesn't suck the galaxy down in it? In a way, it says it has like a vacuum to it. We gotta get to the bottom of this. Okay, what we're learning, we don't have all the answers. What I'm teaching you is bringing up more questions. So I thought that the black holes would suck in anything and everything. And it says black holes are at the center, many of them are at the center of the galaxy. Well, how can they not be sucking the galaxy into them? I'm going to have to research that tomorrow. Like Sagittarius, in the Milky Way, influence star formation and the distribution of matter. So I looked up matter the other day, and it means, anything tangible, anything you can feel, taste, smell, see, hear. No, it has to be tangible, though. Yeah, that's what matter. So they'll say, like, the black holes are made up of matter. So they have, objects in there. And yet they suck everything. So I'm going to have to research that and really, because we're left. You're not. You got to be wondering the same thing me, because they keep saying the black holes suck everything in at a high, unbelievable. Even light can't get out. But then they're telling you there's mass in there, matter in there. So I'm going to have to research that. Okay. So so it's the Sagittarius in the Milky Way influence star formation and the distribution of matter. 2, quasars, : some galaxies host active black holes that consume vast amounts of matter. Here we are back to matter. It's just anything tangible, they say. Creating quasars, extremely bright objects, visible across the universe. These quasars, continue. These quasars provide insights into the early universe. 3, black holes. I don't know how they know. They can determine the quasars are from into the early universe, like they're saying years ago, like centuries ago. Is that what they're insinuating? Is that what you think? I might be, yeah. Okay, so black holes mergers it says mergers when galaxies collide. So I didn't know galaxies collide, did you? Their central black holes can merge, releasing gravitational waves. These events help scientists understand the dynamics of galaxy interactions. 4, time and space. Distortion, black holes warp space and time, creating phenomena like I gotta read this. Like it's fat magic marker, so I'm gravitational lensing, L-E-N, and sing, like you're singing, L-E-N, sing, lensing. What is that? Gravitational lensing or gravitational? It's I don't know. Gravitational lensing, L-E-N-S-E. I'm going to have to look that up tomorrow. This allows astronomers to study distant galaxies and the universe's structure. 5, cosmic recycling. Black holes can eject jets of energy and matter, redistributing elements. NASA across galaxies. So they're saying across galaxies also. And contributing to cosmic evolution, black holes are not just cosmic enigmas. They are key players in the universe story. They're saying universe's possessive story, which expect have their influence on galaxies intrigues you most. Oh, what? Oh, it's asking. No, I don't want to ask you that question. That's the book. Forget that. Okay. So, there's one last page. You're going to have to watch this over and over because you're not going to remember all this. I'm not going to remember all this. There's so much amazing, and it's things we never heard of. So, at your own pace, please watch this video 5, 6, 7 times and listen the whole time as much as you can. If you have to take a break in the middle of it, you could take a break, or you could pause it till tomorrow, or come back and start it over again, something like that. So here is, this is page 9. NASA has made some truly made some mind-bending discoveries about black holes and galaxies in recent years. Here are some highlights. One, the sideways, quote unquote, black hole. NASA researchers uncovered a supermassive black hole in the galaxy NGC 5084. You see how they're numbered and lettered? I'm starting to see a repetition to the names of like the exoplanets. They're all similar, like proper nouns, like 3 uppercase letters and then some numbers, and usually a little lowercase thing floating around there. I don't know, that's how they... So this galaxy is NGC 5084. There's no little lowercase thing floating around. That rotates at a 90-degree angle to the galaxy itself. This tipped over. So this tipped over orientation is rare and was revealed using advanced image analysis techniques on archival data from the Chandra X-ray Observatory. Fascinating. Okay, we got more. Well, I'm being a bad girl. I went this afternoon and bought me some sweets that I might end up eating after class. Well, I'm teaching 2 classes. So, and when you're working, it makes you more hungry. You know that. But I still have some healthy food I think I have to eat first. Okay, so NASA, black holes, galaxies. Okay. Supermassive black holes outgrowing their galaxies, studies using data from NASA's Chandra X-ray Observatory, quote unquote. That's a proper noun. And other telescopes showed that the largest black holes in the universe are growing faster than the stars. Now, you remember this. You got to watch this over and over because you're not going to remember all this. And it's very fascinating facts. And the more we watch me over and over, you start to memorize. And then you get more interested in the next video. And and because you're going to understand the next one more, and it's going to get more and more interesting if you really make an effort to watch me over and over. And you can take notes if you want, but watch these over and over till you get it. Okay, so we're going to start over. 2. Supermassive black holes outgrowing their galaxies. Studies using data from NASA's Chandra X-ray Observatory and other telescopes showed that the largest black holes in the universe are growing faster than the stars in their host galaxies. Yeah, this challenges the idea that black holes and galaxies grow in tandem, period. 3. Hubble census, CENSUS, Hubble census of black holes, okay, NASA's Hubble Space Telescope, so it's the name of a telescope. Hubble census is Hubble Space Telescope, conducted a census of nearby galaxies and found that nearly all large galaxies harbor supermassive black holes. That's fascinating. They also conducted a census of nearby galaxies and found that nearly all large galaxies harbor supermassive black holes. These fossil quasars, quote unquote, provide insights into galaxy evolution. So these fossil quasars provide insights, learning about the galaxy evolution. It's all an evolution. The dwarfs are evolution, the solar system's an evolution, Earth is a revolution. Here on the streets of Illinois, all the countries on the planet Earth are evolving every day. Every country, every person is evolving by the hour, by the minute, by the second. Life is all evolution. That's correct. And repetition. So, and new things happen though too. Don't just think it's all repetition. They say history repeats itself. That's true. But there's also new things that come about. Infinitive, we will be learning for the rest of our lives, or my life anyway. I'm going to be teaching it. And we'll be learning for the rest of my life. Okay, and hopefully yours too. You're finding this interesting if you start listening, right? So all large galaxies harbor supermassive black holes. These fossil quasars provide insights into galaxy evolution and the role of quasars in shaping galaxies. NASA, still black holes. I kept researching because they told me a while back there's tons to learn about black holes and galaxies and telescopes, tests, and all that. It'll take the rest of our lives, and we'll never finish the study. Okay, so now NASA, black holes are fascinating cosmic phenomena, and their interactions with galaxies have led to some groundbreaking discoveries. 1. Galaxies and black hole formation research has shown that black holes and their, quote, host galaxies, quote unquote, co-evolve, period. The mass of a black hole is closely tied to the mass of the galaxy's central bulge of stars. I remember writing this down, okay? Tied So the mass of black holes is closely tied to the mass of the galaxy's, quote, central budge of stars, unquote, whatever that means. The word is budge, B-U-D-G-E, yeah, the central budge of stars. This relationship suggests that black holes grow by consuming. Okay, this relationship, okay, suggests that black holes grow by consuming gas and stars during the galaxy formation process. Wow, this is stuff you never heard of, I'll bet. 2, supermassive black holes. These black holes found at centers of the galaxies, which I mentioned earlier, can weigh billions of solar masses. Can you get this? This is getting more confusing. It says number 2, NASA supermassive black holes. Colon. These black holes found at the centers of the galaxies, they can weigh billions of solar masses. But then how do they call them holes? How can a hole weigh billions of solar masses if they're calling it a hole and it sucks everything in? How is it holding? Yeah, it locks the mass in there. That part makes sense. But supposedly, I don't know. We'll have to keep working on trying to understand this. So the black holes, the supermassive black holes found in the centers of galaxies can weigh billions of solar masses. And I told you masses is, I told you matter is tangible, something you could see, hear, smell. This says weighs billions of solar masses, okay, which is just objects also, pi. Solar masses, billions, weighs billions of solar masses. They often blaze as quasars, the brightest objects in the universe. Wow. When actively consuming matter. See, here they are with matter, the word matter. It says the brightest they often blaze as quasars, the brightest objects in the universe. Wow. When actively consuming matter. When actively consuming matter. Isn't this complicated, kind of? It's not so complicated. It makes you keep coming up with, you got more questions. Well, hey, I want to know this, I want to know that. That don't make sense. Explain me more. And I have to think of all these different weird questions to get these answers that you probably got the same questions. Okay, so 3, galaxies feeding black holes. If you ever want to take notes, and then look up questions that you think, that it makes you think, I didn't tell you because I have to look up myself. Okay, so you could take notes and then Google it in your computer. Hey, how does this go with that? What I'm teaching you right now is causing me like 1,000 questions. Yeah. Okay, so 3, galaxies feeding black holes. Observations have revealed, quote, little red dot, unquote, galaxies they're called, with supermassive black holes that are unexpectedly large. Scientists are still investigating why these black holes are so massive. Okay, good. We only got 2 pages left, because we've been at this a long time. Yeah. Okay. So, when galaxies interact with black holes, the effects can be dramatic. Quote, colon. I kept asking the internet, what about galaxies and black holes? Tell us the most exciting, famous, because I know it goes on. It's infinitive info. So they're telling me what I'm telling them to do. When galaxies interact with black holes, which is what I wanted to hear about, and I told him that, the effects can be dramatic. Matter consumption, black holes consume stars. Look at that. Black holes consume stars. See? Gas and dust from their surroundings. The process can create powerful jets of energy and radiation. No. Yes. Okay. Next one. Event horizon : anything crossing the event horizon of black hole is pulled in and cannot escape, not even light. Galactic dynamics. Black holes influence the motion of stars and gas within galaxies, shaping, their structures and evolution. And last one, 14 pages was this class. The other class, I don't know, was 9 or so. The mysteries of black holes continue to captivate scientists. And ongoing research. See? I'm gonna be researching this for life. And I'm working for NASA because I read a whole page yesterday. You can help, they're saying anybody in the world can help us, NASA, by doing this, by doing that, and doing this and doing that. You don't have to be this, you don't have to be that. We have the equipment to give you and all this crap. And they said, or one of the suggestions was, or you could teach us. And I said, that's exactly what I'm doing. I'm teaching NASA. So I am working officially, legally working for NASA, even though I'm not getting paid. I am still working very hard for NASA and teaching them. And NASA wants as many people on this planet to know what's going on with NASA. NASA doesn't want a bunch of dummies, We're between 7 to 8 billion people on this earth. I always Google our population on Earth for the past 5 years. I've been doing it. We were between 6 billion and 7 billion. And then a few years later, I go back, not too long ago, and it's up to between 7 to 8 billion people are is our new population. So we are having more babies than people are dying, see? Because doctors are finding so many cures and keeping people alive. In the old days, they couldn't keep you alive because they didn't have any cure for it. That's why more people are living longer and having more babies than people are dying. Do you understand what I just said? Think about it. All right, so the mysteries of black holes continue to captivate scientists and ongoing research. It's uncovering more about their role in the universe. They are cosmic giants. We'll have to look into that. When interests you the most? Well, I'm not asking you that question. You can just ask yourself what interests you the most. And, you're going to have 10 questions. Uh-oh.